Hi and welcome back to another Weather Wednesday video. I'm Oliver Silén, Center Manager at NJK, and today we're going to talk about the sea breeze. We're going to talk a little bit about how it's formed and then also about how it affects the tactics of sail racing, and lastly how you can spot it. And after this lecture, in the upcoming weeks, we'll move on to the quadrant effect and also the stability index, which are ways to see if there will be a sea breeze or what other kind of weather phenomena there will be to determine your tactics for the day. So here we have a pretty simple and nice illustration of how the sea breeze works. So we see it's a nice warm sunny day, and we have the land mass here. And what happens when the sun starts warming up the land is that the air on top of the shore starts expanding. And from there, when it expands, it pushes some of the air up, while the air doesn't expand at the same rate out on the ocean. And that causes the air to start gliding down and out towards the ocean. And from there, it drops down, or actually it creates this kind of lower pressure here, kind of a void on shore because of the air rising up and expanding, and that starts pulling in the wind or the air from the ocean, and then that creates a void here which drops the wind down. So we get this nice circular motion, and this is why in sea breeze conditions the wind direction down low will not be the same as the direction the clouds are moving, if there are any clouds. So it's due to this circular motion of the wind. And now why does this matter for a sailor or for someone racing and sailing specifically? And it's due to the effect it has on the wind. Now in a sea breeze, the wind it acts in a very specific way. So generally, due to the Coriolis effect, which we'll again not talk more about, if you're interested, go ahead and Google the Coriolis effect. A lot of interesting information on how it affects the weather overall on our planet. But generally, the wind will, over the course of the day, it will turn a little bit with the sun. So in the northern hemisphere, it's gonna have the wind veer with the sun, so turning right a little bit, but it's also gonna affect the smaller shifts during the day. How much the wind shifts, both in pressure and in wind direction. And the main reason why it affects these wind shifts and the pressure differences and how large these differences are is that it affects the boundary layer thickness. So the boundary layer would be the layer of air where the wind is turbulent and where it's affected. So we have a top of that level in which the air and the wind it behaves in a different way. They're not kind of connected, these two systems. So below a certain level we have the turbulent wind that we're sailing in, and depending on how deep this boundary layer is, or how thick, how high up this boundary is, that changes how big the wind shifts are, how big the gusts are, or how big the difference between the gusts and the mean wind are. And when we have a sea breeze effect, then we have a very low boundary layer, and as it's lower, there's less room for the turbulence to go up and down and back and forth, and that also makes the wind shifts much smaller. So the wind shifts and the pressure differences in a sea breeze will be pretty small, and that makes the tactics a little bit simpler in a way. You don't have to think about the wind shift, the gusts as much. It's going to be more about having good speed on the race course, and you can also be fairly confident that the wind shifts will be pretty symmetrical. So they won't be, well, they're going to be kind of predictable. They're going to be going back and forth, but pretty small and rather fast as well. So, and then you can also expect the wind to turn right during the day. And conversely, if we have a very thick boundary layer, which we will talk about more in upcoming lectures, then the wind shifts and the gusts will be bigger as well. Alright, so now how can you spot that a sea breeze is coming? Now, first and foremost, we need it to be a warm day and preferably sunny day. If we have a lot of cloud coverage, we're not going to get a sea breeze because there's not going to be enough heating of the land to create this airflow, this circular motion of the air. And also, if the water is cold, that's going to help create a bigger difference in the air temperature over the ocean, the sea, and over the land. So that's also going to help with getting the air moving. And we also need the mean wind, or the gradient wind that we call it, the wind caused by the low pressure and high pressure systems that you can see on the pressure maps. We need that to be kind of calm. Doesn't need to be completely calm, but if we have very strong gradient winds, say from the north here in Helsinki, then we're not going to get a southerly sea breeze. If we have, say, 20 knots of northerly wind, the sea breeze effect won't be strong enough to switch the wind 180 degrees. It might make the gradient wind slightly less powerful. And lastly, we have this statement here of not having easterly winds. Now this is not a general thing that applies everywhere in the world. This applies specifically to south and southwesterly coastlines like we have here in Helsinki or southern Finland overall. So, for example, easterly winds in a northerly shoreline, that might be a good thing. So, but we're gonna talk more about this in the next video when we talk about the quadrant effect there. I will explain why the easterly winds kill the sea breeze, but just for now you can know that if you have an easterly gradient wind, so the mean wind or the normal wind that is expected during the day, if it's forecasted to be easterly, you can be fairly confident that you won't get at least a strong sea breeze. You might get a little bit of a sea breeze, or then quite commonly if we have a very warm, sunny summer day, but with easterly gradient winds, then often we see the sea breeze and the gradient wind fighting each other. So maybe the wind shifts out to the ocean for a while, but then it dies out again, it starts filling in from the east, then that kind of dies out, it goes back and forth between southerly and easterly winds here in Helsinki, so that's a common thing. But indeed, next video is going to be about the quadrant effect, and then you'll get to know why the easterly winds are bad. Thanks, and as always, if you have any questions, just leave them down below, and I'll be happy to answer them.